So what is blockchain? If I have to define blockchain, I say it depends on whom I'm talking to. Even in this, people in front of me in this event, there are people from different backgrounds. So if I have to, if I talk to the technical person, I always talk about data structure, database, and so for me, the definition for a technical person will be globally shared and secure data structure that maintains a transactional backend database that is immutable, that is append only. You cannot change. You don't have a CRUD if you will create, read, update, and delete. So the technical people will understand that. If I'm talking to a business person, then I'll talk about a business network that is used between peers to exchange value. Value can be currencies, tracking information, or anything that interested parties require to be maintained on a blockchain ledger. If I talk to a legal person, then I'll talk about corruption resistant string of ledger entries. So it will depend on whom I'm talking to really strike the chord, to really see where the value proposition lies for that person. So, and also blockchain is not something that has been, it came out just like that and an invention. It's something that existed long before, but it's a combination of different technologies. And what are those technologies? It's peer-to-peer network. That means there is no intermediary. There is machine-to-machine communication. Nodes talk to each other in a simple way. Private key encryption, we all know public private key exchange, where you can have the hashed cryptographically hashed data that you transfer to someone, and if they have the public key with their private key, they can just decrypt that data or see that data. And programs, what I mean by programs is the smart contract. So it's like the combination, it's the mix of these three existing technologies that makes up a blockchain. So if I have to compare, if I have to give you a visual, think of a book. So if you take a book with different pages, it's a blockchain, and the page is a block. And every page entry that you write, the ledger, what you have, in the old days. So every entry that you make is a transaction. So one block, once you finish the transaction and the block and the page is over, one block is over, and every page is linked with the other page, right? Because after the first page comes the second page. In a very simple way, I'm explaining. So book is a blockchain, page is a block, and every entry is the transaction. And think of this book as an append only. You cannot go and erase something. You can only write down and continue writing. You cannot erase. And everyone participating in this blockchain will have this copy of the book, same book. So whenever you write something, the next somebody having the same book will have the same copy of the same transaction or the page entries. So that way nobody can cheat with the system, because everyone has the same copy. That's why the trust is built in the system. Trust is in by design. So this is the analogy with the notebook or a book that I like when I talk about blockchain. So now I'll give you one more definition, a little technical definition with a lot of jargon. So, but still I'll do it. So blockchain is to value as the internet is to information, which I always say this, because what you did before on the internet is you exchange information, and what you do with blockchain is you exchange value. So you will see what it means. Maybe by the end of the event, or by the end of this training, you will understand that better. So if I have to define blockchain, it's a distributed ledger that allows digital assets to be transacted in a near real time immutable manner. What I mean by distributed is there is no single ownership, there are multiple contributors, and no third party. It's shared peer to peer, and disintermediation comes naturally because it's distributed. What I mean by digital assets, it's something represented in a digital form that has an intrinsic or acquired value, like land, house, vote, currency, identity, reward, certificates. And what I mean by immutable is like it's an opponent only, you cannot change, you cannot tamper with it. And to wrap it up, I also wanted to have these three properties: low friction, cryptography, and verifiable. Because when you have this system, blockchain, it's all about secure, which I talked about, public private key. It's verifiable because every transaction is there, nobody can tamper. So you can backtrack, you have an audit trail. So these are the features you will keep on hearing again and again and again, because this is what blockchain is all about. This is the properties, these are the principles that makes it so revolutionary, which I'm also going to stress on again and again. So that being done said, you have different kinds of definition. It depends what sector, what background you come from, and which definition you like the more. So the history of blockchain and why the history is so important to appreciate. If we look at the evolution in 2008 2009, when the first paper, Satoshi Nakamoto, when he wrote the white paper on peer to peer exchange of value, that was the paper on Bitcoin. So that was about digital currency, about distributed ledger, about Merkle tree, which I'll explain a little bit about Merkle tree, proof of work and mining. So this was the first blockchain 1.0 before around 2010. Then came Ethereum, which was inspired by Bitcoin and the drawbacks that it has. So in around 2014-15, blockchain 2.0, because what Ethereum did was implemented smart contracts. Programming came into existence with the blockchain, and there was decentralization and distributed apps, D apps that you keep on hearing started, and that's blockchain 2.0. Then blockchain 3.0 is all about DeFi. You keep on hearing, decentralized finance, high speed and interoperable, because they were able to exchange little. Still, it's not that interoperable yet, but there are things going on that will make it interoperable. But there are certain ways where you can communicate some kind of information from one blockchain to other. So that was blockchain 3.0, and blockchain 4.0 is in the future. It's not yet there. It's 2030 or beyond, even 2025 you can say. It's all about industry 4.0, where IoT, AI, blockchain and self sovereign identity and everything comes together, and you make a perfect ecosystem. So if I have to, so this is what the evolution of blockchain, the past, present and the future. And Gartner also really, if you see, it maps very well with what Gartner came up with, this blockchain spectrum. So what I told you was 2010, before to Bitcoin, it was the era of Internet of Information, enabling technology, you exchange information, what you do on internet. Then came Bitcoin, and then it changed and it became, and that era was Internet of Content, where Facebook and all those things, you share your content and everything. But at the same time, that was blockchain inspired. Why? Because you saw it was only distribution, encryption and immutability. They were lacking some features, which you see in the later on when Ethereum really developed, when different kind of blockchains came into being. It became Internet of Value, because you were exchanging value. You already know now NFTs and all those things. You send, there is different kind of assets that you trade, and that's why it's called Internet of Value. And it became blockchain complete, because it had all the features that when we define blockchain, it's distributed, in encryption is there, immutability is there, tokenization and decentralization. That makes it blockchain complete. And beyond 2030, we say it will be enhanced blockchain, because then the power of the trio, the AI, IoT, blockchain, comes together to make it really powerful and self-sufficient to implement in different domains that you can imagine. So that's what the blockchain evolution has been till now, and in the future it will be. So I will now talk a little about blockchain versus traditional database. What's the differences? So when we talk about the legacy architectures and databases, they are basically centralized repositories of managed data. This data is structured and controlled centrally. Somebody is controlling it. But blockchains are decentralized and distributed, meaning nodes on the blockchain are distributed, and there is no one single authority controlling it. SQL, NoSQL, whatever you use as a legacy database, is they are the most widely used, SQL or NoSQL. That's what I'm trying to say. But blockchain do not use any SQL or relational database structure. If you see later on, it's just simple JSON kind of or very simple data format that you put on a blockchain, and if there is something complicated or heavy, then you put off chain. So we'll see there is no such kind of SQL or NoSQL ways of storing data. So you don't have to go into this kind of queries or languages for storing data. Whether centralized or distributed, traditional database use client server. So there is a space missing, but anyways, so there is a master slave client server architecture. But from the very beginning, when we talk about blockchain, it's decentralized. There is no one master or one or slave kind of architecture. It's distributed, it's decentralized. There is no one party controlling it. And so definitely the most important thing when people think about is, so what is the transaction speed? Like if databases are there, it's centralized, definitely it will be faster. There is only one party to decide what has to be done and what not has to be done, what is correct, what is not correct. But in blockchain, when transaction happens, everyone has to verify that. So definitely that takes time. So that's why it becomes slower. So that's one of the disadvantages you can say, but we have ways to come around that. And control of the database remains with the designated authority. So from the very beginning, we are saying centralized and decentralized. So definitely there is a control in SQL, MySQL, legacy databases, but in blockchain that is not the case. So now we slowly segue to what is a permissionless blockchain. Why I'm saying permissionless? Because it's something that is public, that everyone knows, like Bitcoin or Ethereum, and everyone knows about it because it's accessible to everyone. We don't talk about enterprise blockchain because not any public or guys like you, like any normal person don't have access to enterprise blockchain. So I want to start with the public blockchains like Ethereum, like Bitcoin. So what does that mean? It has why it is called permissionless, because you don't require permission to access the information or log into it or do some transaction. It's open to everyone. So what are the features of this kind of public or permissionless blockchain? Is global computer network. That means distributed nodes with no centralized control of nodes. It's ubiquitous because it's present every. If you have the internet connection, you can have access. Censorship and tamper proof, because no entity can modify or delete data. As you know, it's public and every transaction has to be verified, and every node has to validate that transaction. Open source, of course, everyone has the right, they can, and they can go ahead and see the code and modify and have their own version of blockchain. Sometimes we call it a side chain, where when people had problems with Bitcoin, they created Bitcoin Cash because the transaction per second was slow, the block size was small. So there are different trade-offs, when you architect a solution using blockchain, and you find that this is not working, that is not working, which was the case for the last 10 years. People are blockchain is evolving because of the constraints and the problems and the cons that they saw with blockchain, and they created their own. And that was only possible because most of the code is open source. So that's another advantage and another feature of public blockchain. Compliance, so comes with smart contracts that are validated. The blockchain ledger also is verified by audits. So it will depend on different scenarios, different use cases, and different countries with different regulations. So that also you have to keep in mind. Multiple users, of course, it's a public blockchain, so there is no limitation to who can join the blockchain. Trust is at the center because we are talking about in no intermediaries, just a smart contract, code written on a machine deciding on its own based on certain events. So it's everything is programmed, and if done correctly, normally that is the case. It will work on its own, and you don't need to trust the system. That's why we call this trustless sometimes. So guarantees, because it's atomic. There is no that if the transaction is going to pass through or it will not pass. It's not like half. It's complete. And provenance is all about knowing the origin. So that's why it's helpful in tracking, backtracking, or having the audit trail of where the something came from, what was the origin of it. So all this makes public blockchain really what blockchain is all about, because then whatever you will see from now on, different varieties of blockchain or types of blockchain, is not in the real sense blockchain, because private blockchain, they privatize it and it's kind of centralized, and then there are hybrid blockchain, and then there are different kinds of blockchain. But this is the real definition and real idea behind blockchain, to be public and open and everyone can use it. There is no control, no single authority to control it. So that being said, why blockchain? Why blockchain is so revolutionary? I think you have picked up from here and there that it is a syncing of technologies. I told you it's peer-to-peer, programming, and cryptography involved. These three things coming together to create this innovation, what we know as blockchain. Um, Trust is at the center of blockchain technology, because there is consensus. I'll tell you what consensus is if you don't know in the next slides. So because they use consensus, that removes intermediaries from the network and thus creates new efficiencies that companies can really benefit from, such as providing transparency, a root of trust, a reduction in labor cost, and numerous other benefits. Blockchain technology, in its true sense, as specified by Nakamoto, is a tamper proof public ledger of value. The Bitcoin platform enabled citizens of the world to make transactions without the need of intermediaries. That was the revolution. That was the paper that changed everything. And to summarize again, I'll say it's thinking of technologies, trust is at the center, tamper proof, it's disruptive to the status quo because legacy system like databases are out. It's not out, but still like you understand. And the platform, it's a platform where you can build on top of it. So you can come up with any use case, and if really blockchain can be used to really make this to solve the problem, then blockchain enables that enables you to create that solution. So, in a nutshell, blockchain is a complex tech, but is a simple concept. Trust is at the center. Blockchains are ledgers shared among computers around the world. The ledger in a blockchain are immutable, tamper proof. You cannot cheat with the system. Blockchain is not a new technology, but syncing of tech. So that's in a nutshell what blockchain is and why it is so important and revolutionary. I said, but then I want to show you how much value is there. By Gartner, they have projected like the business value add will be 3.1 trillion by 2030. Why is it important? Because it's just showing that how much value is there to be captured in the market, and if SMEs like you are really know where the value is, where the value lies to be captured, then only you go there, and you if you capture some of that, then that's the whole purpose of doing a business, right? Creating a business and again one more impactful number that while I was doing the research I got was 10% of the global GDP will be stored on blockchain by 2027. So you can just imagine if you calculate that, if you're talking about the US GDP, again it comes to trillions, 3 trillions, easily 2.8, 3 trillion. So there is a lot of value out there. We need to capture it by innovative solutions, by creating solutions to the problems. So let's go into some of the principles behind blockchain. And you have seen so far what blockchain, why it is so important, innovative, and solve different kind of problems. Because first thing is it's immutable, cannot be changed or altered. It is decentralized. There is no single party governing this. There is no single authority. Distributed, not one person just has a copy. Everyone participating in the blockchain has the copy of it. So nobody can say, okay, this is wrong, this is right, because everyone has a copy. The truth is there in front of it. It's transparent. Secure because everything is cryptographically hashed. So by design, it's secure. Consensus, it's a decision making protocol where whatever happens, any transaction that you do on a blockchain has to be validated by other parties, and there are different algorithms which we call consensus algorithms that we'll see a few of them, like proof of work, proof of stake, Byzantine fault tolerance, delegated proof of work, proof of elapsed time. So different consensus algorithms are there, depending on the architecture, depending on the trade-off. What you want it to be quicker, you want it to be more secure, because Bitcoin is the most secure, right? So they use proof of work consensus algorithm for decision making, and proof of work, as you all might know, uses a lot of energy. So it's not environmental friendly, not eco. So it's not advised, and that's why many people, they don't like to go with Bitcoin. And anyways, right now nobody develops any solution based on Bitcoin way of working. That is proof of work. That is totally kind of not suggested or advised to do so. And faster, I'm saying near real time, because it will depend on the architecture. If it is a private blockchain, it will be faster. If it is Bitcoin, then forget. You have in 10 minutes one block is created, and you have like only 4 transactions that you can do per second. So it's very slow. So it's out of the question. But if it is a private blockchain or a hybrid blockchain, then it depends. It can be done in near real time. So these are the key features that any blockchain revolves around. There is different kinds of, it can be faster, slower, consensus can be different, but mostly these are the features of blockchain. So now you know what features blockchain has. It is immutable, it's distributed, it's decentralized, and consensus is there. But how does it all work? I told you, I gave you an analogy of the notebook where the pages and every entry is a transaction. So how does it look like in a real blockchain scenario? So imagine a block. So you have the first one is the block header, and what happens is every block will have the block number and your data and the previous hash. That means whatever is in the previous block, it hashes everything. Hash is nothing but every content is just they are just encrypted using SHA-256 algorithm. Right now they are using this, but it can be more something else in the future. And you have a very encoded message, which I'll show you how it works. But the important part here is the Merkle tree that I told you. So what happens is you cannot have every transaction. Every transaction is hashed, and then that hash of the transaction is also hashed together, and all these hashes create a Merkle tree. So just for example, transaction 0 on the left side, you see transaction 0 and transaction 1. So you have hash 0 of the transaction 1 and hash 1 of the transaction 1, and this creates hash 0 1. So that means all the transaction will create these kind of pairs. So you all the transaction will come together, and at the end you will have hash 0 1 2 3. That will be the Merkle root that you will put on the blockchain. So to make it more clearer, you see something like this. So what happens is block 10 will have the previous hash, which is the hash of the block which was preceding it, the timestamp, the transaction root is the Merkle tree, Merkle root I am talking about, and the nonce. I'll tell you what nonce is. So you see, has transaction 1, transaction 0 becomes hash 0 1, transaction 2 and 3 becomes hash 2 3, and then the transaction root that you see will be hash 0 1 2 3. So how it works is basically now a better picture is a block. You have the block header, you have your data. That is the transaction that you are doing. It's whatever data you might have. Think simple that you have some coins and you have to transfer it from Alice to Bob or whatever. So data is Kirill has these coins and he gave it to Hadlin. Kirill gave it to eBay, and then he gave Hadlin some more coins. Then there was a previous hash, and then there is a hash of this whole block. That means block header, data and previous hash coming together to create a hash, and this hash will go to the next block. So what is missing here? You will say, okay, fine, it's very easy. You hash everything and that's the block. Then what's the big problem there? What is mining all about? There comes nonce, which you see in the right hand side, because you cannot tamper with the data. So what you can do is create a variable, a random which is number used only once, nonce is number used only once, is something that you can change, but you cannot change everything else. What will happen is this: if you change the nonce, the red hash, the complete hash of the block will change. And why we do this is because that is what proof of work is all about. You have to guess this nonce. So every miner in the world, they are just sitting in, or their computer just running around to solve this cryptographic puzzle to find this nonce. So when you find this nonce, you come up with a target. That is the difficulty we set, that you have to get a certain type of hash. This hash that you see in front of you is not correct because it is not starting with 000. So what happens is, now if you know what the block looks like and what the content is, like the data, the header, the previous hash, the next hash, the hash of the block and the nonce. So now if you have this in mind, what happens when you solve a cryptographic puzzle? So now you see there is a difference between this slide. Just note down the hash, how it starts. It starts with a number, right? On the left hand side, this is the leading side I'm talking about. So left hand side 82b5, 82b5. This is not, this was just making the presentation, this is not correct. Normally every hash should have a leading zeros. That is defined every 2 weeks, or every time Bitcoin decides, Bitcoin protocol algorithm, Bitcoin blockchain decides what will be the difficulty, the target that week. Will it be 4 zeros, 5 zeros, 6 zeros? That is the target, that is the difficulty that you set. Then so one thing you should know, take away from this is like, okay, the hash should always start with leading zeros, otherwise it's not a correct thing. So once you have that, you can play with the nonce. So I'm just showing you the chain of why it's called blockchain. Again, it's a chain of blocks. Blocks are like this, and every hash leads to the next one, and it is linked with the previous hash. But we are trying to understand what is proof of work. Proof of work is all about guessing the nonce and getting to the target hash of 4 leading zeros. How that works? So what will happen, you will see every time the SHA-256 is 64 digit long. Whatever you write, you will always get 64 digits at the end as your encrypted message. So what happens is, if you can imagine, you have 60, because it's a hexa decimal. So every number has 16 different possibilities. So you have 16 to the power of 64 possible hash values. So people think that it's very easy. No, it's not. So what happens is, when Bitcoin sets a target, so you see at the bottom, why at the bottom? Because more the zeros you put, it will come to the bottom, and less zeros FFFFF will be at the top. So I'm saying, let's set a target of 4 zeros. The difficulty is, you have to guess a hash which has 4 zeros. So that belongs there, but it's not something that you can just guess like that. And you, so you see example 23, if I guessed a nonce of 23, it is on the very top, because you will get a hash of FFFFF something. If you guess 21, you came down. So you think it's very easy, let's keep going down. But if you do 22, again it's going down, and you put to 143, it's going. So there is, it's very random, and that's why it becomes very difficult. It can go up to billions and billions, the nonce that you can guess. So once you guess something that gives you a hash with the target, that means 00 starting with 4 zeros, you come to the target line, and the person, the machine that guesses is the first, is called the golden nonce, and he gets the prize. You must have heard of that, he is the miner, and he will get the Bitcoin. Right now it's 6.25 every, I don't know, there is a duration, I'm missing it, but every, it halves. So it was 12.5, and now you get, the miner gets 6.25 Bitcoin if he guesses the correct nonce. So that is the price of mining and making it work. Otherwise, hashing is very simple, but guessing this nonce is, takes the power, takes the energy, and not everyone does it. So that's the whole, in a nutshell, what proof of work is all about. So I think there is a lot to digest, I guess. So I think this is the perfect time to take a break. Yes, yeah, I think so. Okay, so a little bit more technicalities. I think if people didn't understood what I was talking about, maybe this demo will help them. What is SHA-256? What's the whole encryption looks like, and that will maybe help you a little bit. So I'll take 5 more minutes maybe to explain this. So what you see in front of me is, I just want to show what SHA-256 looks like. You see, this is the 64 digit that I'm talking about. You don't care whatever you write, how much line you write, whatever, it will always be 64 digits. That's why the whole probability, the whole nonce thing that I was explaining, you can do whatever we want with the data, and it's not just about nonce. When I talk about the hash, this is the hash. So if you have a picture, a PDF, whatever you name it, any line, any format, I can just copy paste, let's say this kind of format. If I want to copy and paste, it's always going to be the same size. This is the SHA-256 that you should imagine. Like when you hash something, your data, any format, this is what you get. So on the blockchain, what you store is the hash. So it's a reference, and you can imagine that if you hash something and you store it somewhere else, you can store the reference on the blockchain, and it can go search via this reference somewhere else. So once that is clear, what hash is, this is what the block is. So I was telling you, this is the block header, this is the thing, and normally there is no data in it, but it has come up with this nonce. You see, this has 4 leading zeros. That is something that you have to always create. So there is no data in it. But if I change the data, you see it becomes red. Why? Because you already see it is not falling in the target that was defined, which I explained earlier, that you have to achieve 4 leading zeros. That is the correct hash. Otherwise, we know that this is not correct. So you see this, it has become red. So I'll mine it again. Now you have only one block. So you saw the nonce change, as it is only one block, and it was comparatively very easy to find the nonce. And now the block is fine, it's green. So now you know what the block is. So what is a blockchain? So it's a chain of blocks. So now you have more blocks, and everything is green because this is the 00, because this is called the genesis block. So this is the beginning. This is the inception. That's why it doesn't have any previous hash. It's 0, but it has got the hash of its own. That means previous hash, data, nonce, and block. And consider, so you see this is chain of blocks. So previous hash, this one is same as this one, and so on and so forth. So suppose if I have to store some data, something whatever you want, because right now with no data it doesn't mean anything. Let's say that you store name and your property, whatever you want, as I said, but you see it's red now. Why? Because the hash is not as it was supposed to be. There is a rule to follow. So now you mine, you do that proof of work, so that you create, you find this nonce and it becomes green. What happens when you go back in history and change something? All red. Why? Because you see every hash that is not following the rule. So you mine this, you do the lot of work. Uh, Now it's only one chain, it's only one block, only one pair, so I'm mining it quite fast, fine. But this is how, like if you change something, the hash changes and everything changes, so you have to mine everything and come back. So you have to use your processing power, energy to calculate this hash, the new hash, because you change the data. You can trick the system, fine, because it's only one chain. But what do you mean by distributed? That means it's not only me who is there, it's you, it's peer A, peer B, peer C. So there are so many people. So now what happens if I change this blockchain is corrupted now, but it doesn't mean that I cannot revalidate it. I will mine it again to get the correct hash, to guess the correct nonce. So you saw that change. Again I'll mine it. So I'll keep on mining because I have the power right now. It's not much, so I can mine 3 blocks, and I mine 3 blocks, and I got, it's still mining, it's still finding the right nonce. Okay, so what does that mean? This means that I tricked the system and I have something else. But I told you, you have the copy of the same thing. You have the same copy of the book. And now when you see, you have something called as 85888AB, and I have something 38538, and he has 85. So there is a consensus saying that peer C and peer B has the same node but not peer A. That means he has tricked the system. This is not correct. So they will accept only these data, these transaction, this money or double spending problem that you had, this only 100 euros and not 200 euros that you wrote here. So this is how the distributed system helps. So once you know the block, once you know what proof of work, how it works, the distributed system keeps one single source of truth. So now it is not making sense to you, maybe because the data is kind of, you don't understand. So let's put it in real data terms, where Ali is sending Oli some money and Ali is sending Robin some money. So this is, if I change this, the whole blockchain will change. All, everything is red. Again I can mine all this, I can mine this, and it will create the correct nonce. Then I mine the next one. I can mine this, but then the same problem. You will see the consensus is not reached because all the other nodes have a copy, and you are cheating because you are saying you have more, you have $100, but it's not correct. You have only 10, and people can vouch, or other peers can vouch for that. So that's how the whole mechanism of, you see, distributed system, blockchain with, immutable ledger. Because if you change something, the whole has to be changed, and everywhere it has to change, and it takes a lot of mining power, the energy to do that. So if you imagine in the world context, where I'll tell you, Ethereum has like if I'm not wrong, last time I checked it was 16,000, maybe it may be more nodes, and Bitcoin has even 100,000 nodes. So changing all that transaction on every node is huge. It's not doable. So now one question can arise. Okay, but who told you that I have 200? There is no accountability. So I'll show you, like, okay, first we need an account. So I have 100 euros, and then only this is the base. So again there is a genesis. So there is account. Do I have 100 euros? First, yes. Do you have? Then you can do transaction, and then the whole verification and everything. And again it goes on in the same manner. So I hope this combined with what I was trying to present makes sense, and you know a little bit about what blockchain, what proof of work, and what mining is. And so let's deep dive into what are the types of blockchain. We saw permissionless, which is the public Bitcoin. It's an open ledger. The next one is private, which I think most of you will be interested in, because you want higher throughput. You want it only between your, stakeholders. So we'll see. So private is all about closed ledger. It's about closed network and only single organization. Because when we say private, it's centralized. Somebody has the right to create these nodes and he is controlling it, but he is using all the blockchain principles. So if you remember the blockchain spectrum when I was talking about, and I was saying it's blockchain complete and blockchain enabled, blockchain enhanced, and things like that. So it's not complete because it's missing the decentralized part. It's still centralized but distributed. So you have different copies, but only one person is controlling it. So he can tomorrow decide to take off all the nodes, and he can. So that's what the private blockchain is. Private enterprise blockchain. When you hear about this, is the kind of blockchain. Federated is one which is the most use in our context when we talk about different use cases. It's between multiple organizations. It's not the whole world public. No, it's between 10, 50, 20 organizations, and it's still closed. So that's why it's federated or consortium based blockchain, you can call it. And then there is a hybrid blockchain, which is closed, and sometimes some part of it can be public and some part can be private, and that's why it's a hybrid blockchain. So these are the four types of blockchain mostly that you come across. So what are the advantages of public blockchain? As you know, it's permissionless, so anyone can take part and see the transaction. You cannot hide. So if you think about that, the best use case comes to mind is voting, of course, fundraising. So this is a very nice and important platform. These kind of blockchain platforms which are public, to build these kind of use cases, voting, fundraising for startups. So anyone can join the public blockchain, as you have seen, as my your Bitcoin, Ethereum. It brings trust among the whole community of users because there is no central authority. Everything is transparent. Everyone feels incentivized to work towards the betterment of the public network because nobody can tamper, nobody can cheat with the system. It's there, it's out there, it's transparent. So that's why people feel incentivized to use this kind of technology and make it better and better. Public blockchain requires no intermediaries to work. I think I've said it many times. Public blockchain are also secure depending on the number of participating nodes. Security is inbuilt, it comes with the hashing and everything, so it's secure. It brings transparency because it's open and it's proof and it's append only. So whatever happens, everyone can see. So the whole network is know that this is the data and this is the single truth, that everyone has the same copy, so it can be verified. Disadvantages, of course, I told you, like Bitcoin, thousands of nodes, thousands and thousands. So speed will, hamper, and it will be having very, very slow speed. If I talk about Bitcoin, for example, not scalable at all because they simply cannot, because the way they work, proof of work, the mining, it takes a lot of time. And when it takes time, you if you are thinking of real world use cases, real time use cases, you cannot use that because it's totally not possible because of the amount of work behind it to mine the block, to validate the transaction. And that leads to the same problem of consuming a lot of energy in order to mine the block and all this. So this is as I think Tim asked, this is all about in the context of public blockchain, permissionless blockchain. This is the disadvantages, are the disadvantages. So when we talk about private blockchain, it's a permission blockchain that is under the control of an entity. For example, somebody in the supply chain can create their own blockchain, asset ownership, internal voting. So it's an organization creating a blockchain for themselves, so that it's still a blockchain, but it's controlled by one entity. It's faster, as you can understand that this is the only entity with very few nodes, and the deciding power lies with one node or maybe few. So it's very fast, scalable because only a few nodes are authorized to validate transaction. The throughput, the transaction per second will be really fast. The key here is the centralization aspect of decision making, as I think it's very clear, and you can imagine if one authority is trying to make all the decisions and everything is put on one node on a blockchain, of course it makes it really fast. Disadvantages: it's not truly decentralized. So sometimes you can even argue, is it a blockchain? Because it's differing with the principle of decentralized. So so as you have seen in the spectrum, it is a blockchain, but it's not the whole complete blockchain. It's half of blockchain or whatever you can say. Then no trust, because there is a centralized node that is making the decision and keep making it biased if he wishes to. And not secure, because possible to lose security if a certain number of nodes go rogue. Suppose you have only 10 nodes and 6 of them, because you have heard about the 51% attack, so 6 of them just decide that this is not the correct transaction, so they can make the wrong transaction the right one if the 6 of them decide to do so. So it's really possible when you have a private blockchain and everything is between decided between few nodes. So federated blockchain, which I think will be of the most interest and even hybrid. Here it's a consortium blockchain. Some aspects of the organization are made public while other remains private. For banking, payments, research, food tracking, because the public part will be the consumer seeing the journey and all those transactions which are only for public usage, and all the internal parts like invoice and all those things can be kept private. So this is kind of federated blockchain in supply chain, in food. I think for all the SMEs here today, this is something that is very interesting and exciting for them. It offers better customizability and control over resources. Consortium blockchain are more secure and have better scalability, because secure at the same time, because you see there are not just one authority controlling it. You can have the consensus mechanism to make the transactions and everything secure, and at the same time the transaction per second can increase because there are not many nodes validating it, so it becomes faster. So you can scale this to a bigger solution if you have to. It is also more efficient compared to public blockchain network, of course, because it's faster and more things can be done in a lesser time, and there is no fuss about validating and every node, thousands of nodes has to come to an accord. No, it's not the case. So it's much more efficient. Works with well-defined governance structure. All the DeFi and everything has been there. So I think with time, many things have been put in place, and now there are well-defined governance structure around this federated blockchain. R3 Corda, just to name, is one of the federated blockchain which was developed by JP Morgan just for this kind of financial transactions. And it offers access control, of course, because there are not many stakeholders involved, and it has some kind of access control associated with it. So disadvantages of federated blockchain is less secure. Definitely there is a trade-off. So more you go public, more it is secure, but more secure, more transparent. So the same thing comes when you become closer. It's less secure, less transparent. People as they have access control, the regulations and censorship come into play. So and it's less anonymous because it's not public. You cannot see who is doing what. It's only for the stakeholders participating in the blockchain. They can only access the data and they can only see what's going on on the blockchain. So advantages of hybrid blockchain. I am coming to the hybrid now. So a combination of private and public blockchain. So real estate, retail, and highly regulated markets go for the hybrid blockchain. Again, it's the same principle. It's much bigger scale, I can say, than the consortium based. It's just that, but it's the same. Some parts are public, some parts are private. So works in a closed ecosystem without the need to make everything public. As I said, only few things are public, which is totally end consumer based information. Rules can be changed according to the needs. They are immune to 51% attack because it's in the interest of everyone to participate. It's in the interest of everyone to be loyal, and that's why there is no such thing as 51% attack. It offers privacy while still connected with the public network, because there is two branches, right? The public part and the private part. So the privacy remains in the private channel, and then the public part where you can expose the information that needs to be explored, like for in the real estate, what information needed to be there for the housing, like all the details which should be public, and there is no cheating going on behind regarding the price, regarding the construction or material or whatever you can say. So these are the public information that you can put. It offers good scalability compared to the public network. because of course anything public is much more less scalable than any other types of blockchain. So that's that. And disadvantages again, when you talk about making smaller groups, it's always not completely transparent. Upgrading is a challenge because you have thought of in a certain solution, a certain architecture to talk between nodes and all. So when you try to upgrade, it becomes kind of the compatibility issues comes into play, and that's why it's a challenge. And there is no incentive as in the public blockchain to really better it because it's in the interest of everyone. Here it's just the interest of the closed system. So when we now know about all different kinds of blockchain that we have, private, public, hybrid, and consortium or federated one, I wanted to still take away some names and some blockchains which might be of interest to us, to you SMEs. So the most important one is Ethereum, because if you are thinking of anything to make in the public domain, or even just think of voting or whatever, then Ethereum is the blockchain to use. It's cross industry, it's permissionless. So and here proof of work is involved. That's what in today's Ethereum we are going to Ethereum 2.0, where proof of stake will be the thing. What Tim also mentioned. So it's only when you are in the public domain and when you are making trying to do everything publicly, but then there are different routes that you can take, and Ethereum is going for proof of stake while keeping that is a layer 2 solution. That is totally a different talk, maybe for the workshop too. So I'll keep it simple. So it's still consensus is proof of work, and there are smart contracts, and there is a cryptocurrency. There is a comparison because you will see some blockchains that don't have tokens, they don't have cryptocurrencies. So you just have to for today's talk, it has to be clear that there are blockchains, different types of blockchains, and some have cryptos, some don't have cryptos, some have smart contracts, some doesn't have smart contracts. They use consensus. What kind of consensus? And they are public or they are private. So Ethereum is the public one. And the next one is Hyperledger, which becomes is also very important for the enterprise, for the SMEs, for you who today who are here to think of a solution for their different use cases. Hyperledger is a Linux foundation project. It's an umbrella project. So Hyperledger is a blockchain which has a different varieties of blockchain. So Hyperledger Besu, Hyperledger Burrow, Hyperledger Fabric, Hyperledger Sawtooth, different kinds of blockchain. But in general, as I said, different blockchains can be used for different purposes. That's why it's cross industry. It's also permission. It's a closed system, closed ledger, only between the nodes that are the stakeholder nodes, you can say. But the interesting part here is the consensus. Every Hyperledger blockchain, whether it is a Fabric one or a Sawtooth they use their own consensus, and that's create different use cases. Because if you want something faster, you will use something called as proof of elapsed time, which is POET, and that is used in Hyperledger Sawtooth. That is for tracking, let's say, an example of fishing, where the fish comes from. It's for the provenance of the fishing industry. It's very fast, and it's a different kind of consensus. You don't have to wait and do the proof of mining and proof of work and all that. Neither proof of stake. It's just the time elapsed to validate. It's something technical, but it's that. But when you go to Fabric, it uses proof of stake. When you use Besu, which is a very new Hyperledger project, which is a mix of Ethereum and Hyperledger. It's the first time Hyperledger is doing hybrid, which is using the public blockchain as well as the private part. So it is a hybrid approach where they are using proof of authority. So only certain nodes have authority to validate. So it becomes much faster. So these are the things. But if you use Hyperledger and you are thinking of tokenizing your assets or something, you cannot yet. Cryptocurrencies are not implemented on Hyperledger blockchain. And then there are others for financials, just to name a few: R3 Corda, Codem, Ripple. They are used for financial exchanges, and they have different consensus algorithm that makes it faster. As you can see, probabilistic voting, majority voting, and R3 Corda has again pluggable, so they can use different consensus algorithm to on different use cases and different scenarios. So that is a little bit few names, only few names of enterprise blockchain. There is a plethora of blockchains out there, but Ethereum and Hyperledger is the one I'd like to say that is and might be and mostly I think will be of interest for your use cases. So now we know about the basics, we know about little bit around what blockchain is and how it works. So I wanted to just brush up again that what are the core components of blockchain. So there is a node, that is the computer within the blockchain architecture, each has independent copy. So nodes is the copy of the blockchain. Everyone has the all the blocks in the node. So if you become a node tomorrow or your machine, you will have the whole copy of the Bitcoin or Ethereum. That means you have to download all the data. So you should have like terabytes of thing space on your computer if you want to become a node on Ethereum blockchain, for example. Transaction is the smallest building block of the blockchain system. Is the ledger entries or whatever happens, every event happening is a transaction. Block is a data structure used for keeping a set of transactions. You saw the block header, previous hash, next hash, nonce, for example. And chain is a sequence of as every block is associated with the next one with the previous hash, it's a chain of blocks. And miners are people who are just as I described in the proof of work, specific nodes which perform the block verification process, and that process is the solving the cryptographic puzzle. And every time there is a consensus algorithm, proof of work, proof of stake, proof of authority, elapsed time, Byzantine fault tolerance, different kinds of algorithms are there. So these are the components that make up a blockchain. So again, the same thing, but I just wanted to wrap up with showing what the components are. So it's apart from the nodes and everything, cryptography is one of the core components. So we talked about SHA-256 and showed you how it works. Peer-to-peer network, only nodes are talking, no intermediaries. Shared ledger is there. Consensus algorithm is there to validate the blocks, and then there are validity rules, which block, which transaction to put in first. So these are decided by the validity rules. And the virtual machine where you deploy all this. For Ethereum, it's an Ethereum virtual machine, which is like a software platform, software environment where you can make and deploy these smart contracts or build these smart contracts. So this in a nutshell, if there are some jargons, forgive me, but this is something that blockchain comprises of, so I have to mention. And then you can think of in a broad way, blockchain is the foundation, is the layer on top of which you can build any kind of use cases. And protocol for Ethereum is the Ethereum protocol, for Bitcoin is the Bitcoin protocol. So it's the something, it's a code that talks to the blockchain, and then on top of it you can create tokens, cryptocurrency. So if for Bitcoin is the Bitcoin crypto, but the blockchain is also called Bitcoin. So it's not that it's two different things. It is two different things, but the name is same. But for Ethereum, it changes. For Ethereum, the blockchain is called Ethereum. Protocol is Ethereum protocol to communicate to. So whatever code you write, it talks to the blockchain using the Ethereum protocol, and the token, the currency is called Ether. So if you see, so here the name is different. That's why it becomes a little bit more clear that Ether is the cryptocurrency, Ethereum is the blockchain. And then you have your DApps, which is the decentralized apps, which you see you use every time for any DEX, which is a decentralized exchange. For any DeFi apps, everything is decentralized app because you are talking to the blockchain, and as it is a decentralized application, we name it DApp or DeFi or something like that. So I like to compare, give this analogy. So if I have to say what blockchain is, it's like a train track. So it's the enabler. On the track, the train can all the cryptos are the trains on the track. So blockchain is the platform, is the technology enabler, and applications are enabled by blockchain. So if you have to think, it's very simple terms, blockchain is the train track, cryptos or all the tokens are the train on the track. So once we have all this big picture about how it works and everything, I just wanted to show you a little bit about the solution architecture you saw, the components you saw, how to put together everything to build a solution. So from the technical side of it, if you see, there is something called as contract, which is the smart contract, and you create those contracts and you deploy those contracts, which goes on the blockchain, and then it becomes autonomous, and it depends on the events like track and trace or whatever you do, that it gets committed and the transactions get stored on the blockchain. That is the immutable thing that you cannot change. So for Ethereum, I'm showing you something different kind of ecosystem. This is the whole front end, back end that you need to deploy a solution based on Ethereum. So before, I will just give you an example of what is what. So Truffle in the technical terms is something, it's a testing framework that allows you to create, deploy and publish or even build smart contracts. So Truffle is for smart contracts. You have your smart contract, you will build it, and somehow this will help you give you the environment to build, deploy smart contracts on a mainnet. Mainnet we call, or a testnet is the blockchain, and blockchain comes for development with testnet, mainnet, and all those things. So Ganache CLI that you see, the second one, is something you can assume as a testnet, as something which is a fake Ethereum blockchain, which gives you some credits, and you can deploy it using deploying it on Ganache, so that you can interact and build some application before deploying it on the mainnet, main Ethereum net, because it will cost you. And once the smart contract is deployed, you know it, you cannot change it. So it's better to test it, and for that the testing environment is Ganache. And then you go to the front end, where Web3.js is just a library to talk to. And if you know about APIs, which is application programming interface, we have something called as ABIs, which is application blockchain interface. It's the same thing. It's like APIs that you connect with these libraries, and you talk to your blockchain, and simple transaction like, is the account having this money? If he has the 100 euros to transfer to them, if he has, then transfer from amount A to amount B, and these kind of interactions. So if you look at this, we took the contract deployment, so we compile it using Truffle, and then we get the APIs as the ABIs, application blockchain interface, and we migrate it. That means we put it on a blockchain. That is Ganache, for example. Ganache gives me 10 different accounts with 100 Ethereum, fake Ethereum, and then I can do any transaction based on the event that is. And on the right side, you see the front end, where I have a simple web app, which is in the back using Web3.js, which is a library developed to talk to your Ethereum blockchain. So just to, from the technical side, the front end and back end, how it works, very simply put, this is how you see in the Ethereum side of things. So this is the whole ecosystem built around Truffle, Ganache, Web3. Just to give you some names, so you might maybe remember, and this, if this comes up in the future, you know what people are talking about. So that was public. When we talk about Hyperledger, I'm giving you an example of Fabric. I told you there are so many Hyperledger blockchains. Fabric is something that you can use for when you want private data, private blockchain, and still talk to some kind of secret. So, give you an example. I supply fish to different restaurants, but the one which is local, I give him for 50 euros, and the one which is far away, I have both, with both I have good relations, but I sell him for 70. You know, like there is different rates, and I don't want my rate to be public. So I have some channels, I have some private channels where I talk to. So they don't have to know, restaurant A doesn't have to know that restaurant B how much I am selling for, but I can authorize and sell him for a particular price. But the public information, the fish was fished on that particular day, that particular hour, with that particular temperature, and all these things will be public, but only the channel with the price will be private. So that kind of thing is Fabric. And there are other Besu and Sawtooth, which doesn't have channel, which have other things. But if you want something to be private and other things public, this kind of Hyperledger Fabric is the way to go. So you have the front end. I'm just saying, giving. So you have your app, and then it talks again with the APIs, with the Node.js server is turning, and you can think of just as APIs, REST APIs, where you ping pong, where you ask for some information, very simply put. And at the back end, everything is deployed and in the same way as Ethereum. So I'm telling you, like, of course blockchain is a different thing, a totally different world, totally different implementation. But once the back end is done, at the front end it's all about the legacy way of doing things. It all comes down to, it all boils down to APIs, where developer can integrate the API, and nothing else. So your front end, your web developer doesn't even have to know blockchain maybe, and your whole blockchain development can be done and be exposed as APIs to the application that you want to create. That was the point that I wanted to make with all this. So so when we talk about architecture and we are talking about a distributed system, it's always a trade-off. As I told you, scalability, security, decentralization. So what happens is, when you talk about distributed system, there is a theorem called as CAP theorem, which means that you cannot, at a time you can have only two. So either you have availability or consistency and forget about partition tolerance, or you have two of the three. And what does it mean? When I talk about consistency, it means all network node is a distributed system have the same view. That means everyone has the same copy. Nobody is tampering anything anywhere. So you can relate it with blockchain. Availability, that means ubiquitous. When I said you have the internet connection and you should have access to the chain, right? So that means the nodes in the system are available, meaning they are online and accepting requests. So in case of Bitcoin or Ethereum, you can see that they are always available. Then there is a partition tolerance. That means that if a node goes down, other nodes are fine. That's what we call, the 51% attack, or all these kind of attacks. That if something goes down, like Byzantine fault tolerance is one of the ways where we see that if there is 30, even 33% of the node is down or something, it can still work, because that means some way the architecture is such that it is partitioned in such a way that it doesn't matter if few nodes are not working, because the majority of it is working, and we have consensus, and we can say that this is the truth, and you have a source where you can get the information from. So it's available always, it's partition tolerant, and it's consistent. But we say there is a trade-off, because if you have something available and consistent, then it might not be that partition tolerant. So that leads to what we call as the trilemma in blockchain, where we say you don't, again the same thing, the trade off is either you can have decentralization or security and not scalability. When I say that, I mean like Bitcoin is not scalable at all, because it's highly secure and it's decentralized. There is no single authority. It's the most secure and the widest used public blockchain in the world. So it has proved for last 10, 11 years, never has been hacked, never has any problems with the security. So if you want that kind of thing, then you have to forget about scalability. But if you can go off, like suppose you are doing something for 1 cent, or even it's not, money is not even involved, just asset and just information transaction, you might not care about a little bit on security, but go mostly with the speed. Then you can go with scalability and decentralization. Or maybe you don't care that it's decentralized that much, that is private blockchains, right? So it can be very secure and scalable, but not decentralized. So these are the trade-offs when you are thinking of any blockchain solution or architecture, and which one do you have priority for. So you have to look into all those and prioritize how you want to go about it. So just to give you an example again, like when we talk about throughput, what do we mean? So Bitcoin lies way back, you have 7 transactions per second. When you compare with Ethereum, it has 20 transaction. But the best part is, like, we are thinking of scalable solutions. We are thinking of blockchain being adopted, in the mass market. And for that to happen, let's compare it with something, compare apple to apple. If you want something like that to be adopted by mass, then it has to, let's compare it with Visa, which is like the mostly used credit card system in the world, and it has like 24,000. This is theoretical, it can even go up to 50,000, I have read. So you are way far from what the actual thing should be, right? So this is just a comparison that we are not yet there, but we are talking. As you can see, Ethereum 2.0 claims to deliver 100,000 transaction, and there we are talking about something that is really usable on a day-to-day basis. There we are talking, because here today, if you have transacted, or I don't know, but I can tell you, Ethereum, if just a transaction cost, a few days ago I created an NFT, and it costed me just $100 to create one. So not everyone can do that, even if you want to. So just to play out, every time there is a transaction fee, which is called the gas fee, and you have to pay a lot of money, which is not what we want. We want something for few cents, or for transfer of some assets. You don't want to pay hundreds of dollars, or $25 or $30. So this is what Ethereum 2.0 claims, which is a layer 2 solution, where what you do is, you take a lot of load off chain, so that the transaction speed becomes faster, but you keep the security. I'll stop at that, at the layer 2, because it's a huge and totally different thing. But yes, we are almost there, and everyone is trying to have this layer 2 kind of solution, where the transaction is much faster, and the blockchain will be for the mass adoption. So That being said, let's see. Now we know what private is, what public is, what hybrid is. So if whenever you are talking about a solution, you if you have a flow diagram or a template, it becomes easier which one to choose, right? So do you need a database? First of all, if you don't need a database, don't use a blockchain. And if you need one, then does it require shared write access? Is it like one party just writing to it, or multiple parties want to access the data and make changes to it? If the answer is yes, then are writers known and trusted? Because okay, there are multiple parties, but is it a family thing like my mother, my father, and brother, and it's just in the family? Then you don't care. But if trust is involved, then again, if you see, if are writers known and trusted, if they are, then are writers interested, if their interests are unified, because if everyone is looking at the same end goal, if their interests are unified, then there is no trust issue, right? So no need of blockchain. But if there are multiple parties, if trust is an issue, and if their interests are not unified, then do you need a third party? Like, do you need someone in the middle to do that manual job, or it can be automated? If you need a third party, like a manual thing, really you need someone to be there, then don't use a blockchain. But if you need trust, if there are multiple parties, if their interests are not unified, and if you don't need a multiple party, that means it can be automated, then do you need to control the functionalities? If you need to control the functionalities, then where is the control? If it is between the firms, then it is a private. If it is between the firms, then it is hybrid, interfirm. It is hybrid blockchain. If it is internal, then it is a private blockchain. But then let's come to the other side. Do you need to control? If you don't need to control, that means it's totally automated. Then do you want transaction to be private or public? If you don't want control, and if you want everything to be public, then that's in that case you use a public blockchain. So this is the flow, like to check where are the priorities, where are the liabilities, and what we want. And this can give you a little bit, help you to decide at least which way to go. So that was all about blockchain, but now we'll see why we should use blockchain. Does it make sense, from the business side? So we'll talk about the return on investment and the cost of ownership when it comes to blockchain. So return on investment is nothing but talking about the cost benefit, the feasibility, and the risk related to the distributed ledger. So we'll think of how our investment can bring us more value, more benefits, and how we can reduce cost. This is all about the modeling is all around cost, and how we can, if maybe how we can be more efficient in modeling our cost, and how we can reduce the cost that comes up with the blockchain solution. So it's just a definition. It's all about the returns and how much you invest. So mostly if you see, benefits is something that can be intangible as well, but the cost is where the interest lies. For me, especially when I think about the ROI, if I can reduce cost, definitely it gains me a lot. So what are the costs involved when we talk about blockchain, creating a blockchain solution? So it's all about the infrastructure cost, compliance requirement, maintenance and support, development cost, implementation cost, legal review cost, data transfer, data storage. These are in, there may be many, there may be more, but these are what comes to mind when, and the big chunks of the cost consideration goes into these parameters that I'm presenting in front of you. So infrastructure cost, just imagine like just one cost, which is the infra. It consists of leases, utilities, insurance, labor cost, hardware, software, networking, solution design. So there is a lot of things that you need to consider when you are trying to build any kind of technology, but especially I'm talking about blockchain here. So just if you zoom in on the development cost, it is all about the thinking about whether it is off chain, on chain. I told you, like, there is channel, so it's a private thing, and if it is off chain, that means you have to have a database or some other mechanism to store data apart from the blockchain. Then you have integration challenges. You have what kind of consortium you are building, what kind of complexity comes with the blockchain. So you have the flow diagram, but then what kind of data exchange, what kind of regulation. Distributed is fine, but sometimes it doesn't. That geographical area where your node is will not come into the it can be not into the rules and the governance of that particular country, where it will not allow you to have a node in a different area or a different geographical region. So there are different kinds of cost, and you have to think about when you're talking about development. And there are three things that when we talk about the total cost of ownership, it's about startup cost, it's about operation, and even retirement. When I talk about startup cost, it means training for personnel, infrastructure, hardware, software, licensing, consulting. Then there is operational cost involved on a day-to-day basis. Who will manage the chain? Who will see the smart contracts and all those things that comes on a day-to-day basis of the bandwidth, the transaction, the ingress, the cloud services, and all those things. And then the retirement cost. Of course, once done and wrapped up, do you have to archive all those files? Do you have to? There are different kind of things that you have to deal with when you are done with your solution that you are trying to build. So you have to consider the retirement cost as well. So just again a breakdown of TCO. It's about the personnel cost involved, data center, hardware, software, and environmental costs such as utilities, energy, and all those things. So basically, I'm talking about cost a lot because, as I said, everything revolves around cost. If you can reduce that, then you have the ROI will automatically increase. So when you do the model, enterprise blockchain cost model, it's always about the ROI. And when I talk about ROI, you can't do much, but you can invest efficiently, and for that you can see where the investments are good, but mostly you can concentrate on the cost, and that's what we are trying to do. And when you talk about the investment, as I said, you can invest efficiently, and that means you can think of capex and opex, where you can what funding mechanism you can use, and what cost consideration you can keep in mind, so that you can invest properly and reduce costs, so that the factor increases and you have a great return on investment. So one thing that we always talk about is the capex and opex when we talk about any kind of technological when we discuss return on investment. And what I mean by capex is computers and servers, data storage, like the big infrastructure when you have to implement, when you have to invest, and it is for longer duration, 7 years, 5 years. These are big decisions, thousands and thousands of euros. OPEX, on the other hand, is like daily operational expenses, cloud subscription, utilities, network, and rent. And it becomes interesting from the business point of view if some of you might be in the decision making on the other side, on the business side, and you have to deal with it on a daily basis. OPEX is something that is very advantageous. Sometimes you can break it into chunks. You don't have to invest in the whole infrastructure. You can go for a blockchain as a service, for example, and you don't have to pay a lot of money. With few thousand bucks you can start the development, a proof of concept, and you can it's taxable every year. So on your balance sheet, it depends on the strategy of the company, but basically it is much more viable when you think of funding it using your opex rather than capex. But in any case, using blockchain will reduce your capex and opex both, and that leads to a lot of cost efficiencies and gaining. So how you gain that capex and opex savings is when capex is avoided. That means you are not investing in a big infrastructure, because you are going for a blockchain as a service or something like that, smaller, cheaper, and faster. And so in that case, if you use blockchain, again you remember about the intermediaries and many things getting automated. So some of the opex cost is also avoided in that case. So in to sum up, it saves you capex as well as opex. So that is a good thing to remember and know. And then when you talk about the cost, of course, reducing the labor cost, because some of the labors can be removed when you automate some process using smart contract and blockchain, like costless verification, lower transaction, because many things are automated, and everything is transacting on blockchain using the smart contract that you created, that has the well defined rules of every business transaction that needs to take place. So all this is showing you that ultimately you are reducing cost. So so how value is created, if you have seen, if the cost is reduced and your investments are at the right place, your ROI is going to increase. But to make it more clear, I always use this, innovation is the sweet spot in the middle, where when you build something which is desirable, and when it makes sense to build it, financially, and you have the resources to build it, then it this is what innovation is, and this is where it will really fly off or take off and make you profitable. So keeping that in mind, and in the same zone, how value is created when you use blockchain, as you can see, there are three big pillars, and three big, the most important advantages is cost reduction, efficiency improvement, and fraud mitigation. That these three makes your blockchain solution, if you have a problem really pertaining and that you can solve with blockchain, is really something that is of great value and will bring you a lot of return on your investment. Um, so that is there. I just wanted to share a template that I use. So if you see on the top, what value creation is all about is the perceived used value. So when you have capex and opex reduction, when you have security, I'm talking about you as an SME also, where you are creating or capturing value, and even the on the other side, the person using your blockchain solution can also see that. But let me see, as a SME, as an enterprise, my value drivers are capex, opex reduction, efficiency, privacy. So I see there is a lot of value if I use blockchain, and especially blockchain as a service or something like that, to create my solution. And then the cost drivers is data storage and all those things. So that will reduce. That will give me some value, which you see the big blue inside on the side of the value capturing. And then there are effects from my competition, what they are doing and all those things, that will reduce a little bit value. So I will capture what is called the producer surplus, and the consumer, my end, my customers will still feel that they got much more than what they expected. So both, it's a win-win situation, and the profit for us is, it lies in the really in the capex opex reduction, the security, the efficiency, the trust, speed, and autonomy that comes with blockchain. So it's something that I told you, it's not very tangible when you see on that part, but the costs are really something where you can make your effort and create a lot of intangible values, as speed, autonomy, and all that that somehow translates back to something tangible, where, for the end user. Uh, so yeah, so I think we can take a break now.